What up? All right, since my mic is working. Let me see if this works. All right. Hello. Welcome to the stream. I don't know what I'll be doing, honestly. I'll just see um, whatever you guys request. For now, I guess I can do the thing that Baron requested, which is creating a header, but I'd prefer doing it for a simple class, not something like what he requested, which is the Goomba base. So that is that would be way too much, honestly. I really hate enemy classes. They have way too many visual functions. Reverse engineering is basically the process of researching and data mining executables. So, like on Windows, you have exe files. They're basically machine code, basically a string of zeros and ones that the machine can read. It's not the same as programming languages, which are languages humans are meant to understand. So the computer doesn't actually understand programming languages. You have to compile them into machine code, which, like I said, is just a bunch of zeros and ones that the machine can understand, and based on them, it will execute commands. So that's how every application works, and games are also applications. So that also includes New Super Mario Brothers U, and that's basically the process. Reverse engineering is the process where you take the machine code and you try to make sense out of it. Because, like I said before, this is a third time, machine code is just a bunch of zeros and ones, but it's actually equivalent to something called assembly. So, assembly and machine code are actually equivalent. You can, this part here in blue is the machine code, but it's not in zeros and one. It's been converted to hexadecimal, which is basically, um, it's like numbers, but each digit is from 0 to 15. Like a single digit is 0 to 15. But obviously, if you write 15, it's 1 and 5. That's not two digits. So in hexadecimal, it's actually like it goes from 0 to 9, just like our normal number system does, which we call the decimal system. So it goes from 0 to 9, and then 10 is A, 11 is B, and so on until 15, which is F. So the digits are actually like this: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. These are the digits of hexadecimal. So this is, for example, a hexadecimal number, FF, and it's actually 255 in the decimal system, our normal system. So this is the machine code converted to hexadecimal, and each four pairs of these, like each pair is called a byte, and each 4 bytes is an assembly instruction, and they're just basically instructions that tell the computer to do something. So in our case, I have the NSMBU executable. I opened it in Ghidra, which is an application that assists with reverse engineering. And one of the basic tools it has is that it converts the machine code into assembly, and then the assembly into like C-like language. So this is how programmers usually write their code, but the blue stuff here is what is actually contained inside the executable. So this blue stuff is the only thing we have from NSMBU, but Ghidra tries its best to like convert it back to what it may have originally been like, which is this we call it decompilation. So first it converts the machine code into assembly, and then the assembly it decompiles it into C-like code, which is basically this is the code you would usually see programmers use. Some programmers, like the crazy ones, I guess. I mean, they're not really crazy. I'm just joking. But some programmers still use assembly, but the majority of people use languages like C. We call these high-level languages, and assembly is the low-level language. Because assembly is very basic. Each instruction does a specific thing. Like, for example, this copies a register into another register. It's just like a simple thing. It's not like C, where you can have multiple operations in a single line. In assembly, it's just a single operation per line. So the code in assembly would be much longer than it would be in a higher level language. Normally, I mean. Okay, so how do you find where an enemy is? Well, there are multiple ways. I mean, I guess one of them is that enemies are in a specific range in the executable. I think I have like a table somewhere. Okay, I'll have to open Discord, I guess. Nice. Oh my god. No, it's not this one. Okay, so the code in the game is ordered in a specific order, like this. Like each class is stored in a CPP file, and each CPP file is in a folder, and the folders are sorted alphabetically. So when you actually look at the executable, let's compare. So if we go to the top here, the top of the executable, first you have the main function. So the main function is actually before everything. It's because the main CPP file is outside all of these folders. So it comes before all of them. But if you look after, it should be the actor folder. So if we go after the main function, and there are some other related functions that are used by the main function, the first thing we see is an actor function, which basically supports what I just said. Like the first thing we have is the actor folder, which has multiple actor-related classes. You can see in the NSMBU decomp what classes are contained in this folder. Then we have the audio folder and collision, course select, distant view, effect, and then enemy. So enemy, all enemies are in a single folder, and this does not include bosses because I think there's a boss folder. I guess I didn't add it here. Yeah, I didn't add it here, but there's a boss folder. It comes basically before collision because B. Uh, but other than that, all enemies are in this folder. So all enemies are in a specific range. They come after all effect classes and before the fragment classes. So that's one way to find enemies, but that's not how I do it because that's basically too much. You don't have to go that far. Another way is basically first you check in Miyamoto what's the sprite number that you're looking for, and then I have a list, or like the game itself does have a list that converts from sprite IDs to profile IDs. Let's see. I think yeah. This array here basically, the index is the sprite number and the value is the profile. So for example, if we check the Goomba, where is 0? Oh my god. Okay, there it is. So Goomba is sprite 0, and there's a duplicate of it, like a sprite, I don't know which one, but it's a duplicate. So we don't care about that one, but we care about sprite 0, which is the Goomba. And we see now the profile ID is this one, which is 1D3. So 1D3 in in decimal is 467. So this profile ID is the one for the Goomba. Now profile IDs in NSMBU are actually global values. They're not constants. So Ghidra doesn't show it because there's an option in Ghidra that basically inlines constant globals. So they're not literals. They're just globals that are stored globally. And what you can do is you either disable that option, which I don't know where it is, somewhere in the settings, so it can't bother, honestly. So you can either disable that option and it will actually show you the global variable that is being loaded here and stored. Or you can just check it from the disassembly. See here, it's storing R8 in this specific address. I mean, if I highlight this line here, like this, it shows me that it's the equivalent of this instruction. And this instruction is storing R8 in this address. So if we go and check where R8 is loaded, we see that, okay, this is the global variable. So basically, this is the profile ID global variable for the Goomba. What you can do to find the profile now for this Goomba, you can do multiple things to find the profile. The first thing is that you can just check the references for the profile ID because the profile ID is passed to the profile class constructor. And that constructor also, one of its parameters is the build function of the actor. And that's what we need to find the actor. So, like I said, one way to find the profile is to just check the references here. One of these functions, I mean, I know it's this one here because I already named it. But one of these functions basically has the profile ID passed to the profile constructor. That's what we're looking for. We're looking for where exactly the profile constructor is being called because the actor's build function is being used there. So that's one way to find it. Another way to find it is that I think I sent already on Miyamoto a list of the profile names. The profile names are in Japanese, so it's a string for each profile. What you can do is that you can copy that string. For example, for Goomba, it's Koribo in in Japanese. You can copy that string, and then you can search for it using the search feature here in Ghidra. But I don't think you can. You cannot use the correct encoding here, so you'll have to encode it manually and then enter it as hex. So that might be a little bit difficult if you don't know how to do it. Personally, I just do it in Python. I can just type something like this. And I don't have a Japanese keyboard, so Okay. Something like this. So I just copy this here and then I encode it using the correct encoding. This is the encoding that Nintendo uses on Wii U for most strings, except for messages. Messages use an encoding called UTF-16. So if you're dealing with the MSBT or anything like that, you'll need to use the UTF-16 encoding. Also, yeah, Kuribo actually ends with whatever you call this thing, but I don't even need the entire string. I can just use a part of it. Anyway, let's encode it, and you get this. Now, this is like a byte string in Python, but what you actually need is the hex value. So what you can do is you can iterate for each character in this byte string and then just print it as hex. And then we get these values, so then we can search for them here. A3 for A, A3, 8A, A3, 8, 8A, A3, 7B. Okay, that should be it. Then we just search all, and we see like there are multiple results, but the one I'm looking for is just Kuribo. It's like the most similar to this basically. And actually, if you have the list, you should have the entire name, and I already know it's this one. So here, if I check the string, the only reference should just be a single function which calls the profile constructor. Remember, we're trying to find the profile constructor. So there are two ways. The first way is to use the profile ID. The profile ID could be used in many functions, but one of them must be the one that is like passed to the profile constructor. So if you use the profile ID, you'll eventually find it. But if you don't use the profile ID, you can also use the profile name. And the profile name is only used by the profile constructor, so it will only have one reference. Or like in this case, this one has two. This is something else actually. I guess it's like profile resources or something. I don't know. But there are some that will have like multiple references. I think maybe, but all of them should be basically the profile constructor. So if we go to this reference, we'll see that literally the next line is the profile constructor, and the second parameter to this function is the build function for the actor class. So this is what we're looking for. So as you can see, we found it using the profile name. If I go back and try to find it using the profile ID, again, like I said, you will check these references, and eventually one of them will literally take you here. And like I said, I already know it's this one because I already named it. But for you, most likely they won't be named, so you'll have to check them one by one. You'll just search for one that calls the profile constructor. And I'm pretty sure, like, if you already have, like, for example, Lumi's database, he already has the profile constructor labeled. But in case you don't, here it is. It's this address. If you don't have the profile constructor labeled, it's this address. So you just want to look at these references and find the one that calls the profile constructor. Like I said, I already know it's this one. So see, it took me to the same place because the profile name is used here and the profile ID is used here. They're both used in the same function call. So then you have several useful things here. Usually, this profile constructor is called in the static init of the actor CPP file. So you can also find other useful things in this function. You could also find the state IDs. Like, these are all the state IDs used by the Goomba and the Goombrat. Another thing is that you can also find the actor info, which basically specifies some useful things like the spawn range, the offset, like when you place the sprite box in Miyamoto, what's the actual offset from the top left corner to the actor center? It's this value. And this is supposed to be signed like a negative value, but Gitro just doesn't show negative values in the listing view for some reason. Doesn't even make sense, but whatever. And then you can also like see other parameters. We still don't understand what these are for. I think maybe they did find out what they are for in the NSMBU community. I'm not sure, but if they did find out what they are for, they're the exact same thing here. Like they're used the same way. The flags also the same purpose between NSMBU and we, but NSMBU has extra flags, so the values don't exactly match. And then the last value, I literally don't even know what the last value is used for. Or maybe I do. Wait, I think I do, but I keep forgetting. I think it's used in the actor constructor or something. Anyway, let me read the chat. Please post the table on Discord. Okay, I will. I think I already posted. See, I have two tables. I have a table that basically is the profile name for each profile. And then I have another list that is, it gives you directly the profile name for each sprite. Because remember, the first thing I did was that I found the list that maps each sprite to a profile to find the profile ID. And then from the profile ID, you can go to the table I talked about to find the name. I made another table that just skips all of that. It gives you the profile name for each sprite. I'm pretty sure this one is already on Memos. I'm pretty sure I always send that one. Like the first one, I'm not sure, but the second one, I'm 100% sure I did. It's definitely here. Somewhere. I am 100% sure I sent it because I remember that clearly. I just don't remember. Maybe I didn't pin it, but I'm pretty sure I did send it. Oh, there it is. Yeah, there it is. Yeah, this list table, whatever, it gives you the profile name for each sprite. So here, see sprite 0 already, Kuribo. This is Spata Kuribo and whatever. So you can just copy the string and do what I did here to find the hex bytes. If you're used to it, you can do it pretty quickly. Maybe you can even make a script that automates all of this. Otherwise, I guess just stick to using the profile IDs, like the way I showed you. Just go to the table in the game code that maps each sprite to a profile ID. And then in the profile ID references, find the profile constructor. Do that if you cannot do this. I mean, you can just copy the code that I wrote here, and you can do it. Okay, let me continue reading the chat. So what is the range? Like the range for the enemy classes? I can show it in a bit. Sub error function for a new level editor. I mean, honestly, that's probably going to be like very hard. Does Gitro have a dark mode? Yes, it does, but I got used to the light mode. Like I'm personally a hater of light modes, but I've been using the light mode of Gitro for like 5 years maybe, so I just got used to it. I think I already saw the dark theme or the dark mode for Gitro and I didn't like it. By the way, apparently the official name is what? Ghidra? I forgot. I just like calling it Ghidra because it's easier, I think. How do you find what an actor inherits from? Well, you just check the constructor. That's what I'm going to do next. By the way, you can use the hex method on bytes to directly get a hex string. Oh. I think I already knew that, but I forgot about it. Yeah, that's useful. Yeah. I think Kine used to use this in his custom code setup. I'm pretty sure that's where I got this from. I think even old versions of the Cafe Loader project compiler has it. Let me check. Nice, I'm not even signed in. I need to find the old version, so order Logic compiler. I think it's a compiler. Dot hex. Okay. Oh. Oh. It's the opposite. It's the opposite function. This one converts from hex to bytes. Yeah, so we're doing the opposite. But I did know about the hex method. I just completely forgot about it. I'm receiving messages on Discord, but I'm not even looking at them. Oh, it's the guy who needs help with Turing. Okay, so we reached here. This is the profile constructor. Like I said, the second parameter is the build function for the actor class. So if we go there, this is going to be the actor class constructor. So here we have the class for the Goomba. And how do you find the base? Well, it's literally the first function that is called, unless the base is inline. So if you go to a constructor and you see the first thing should be a call to operator new. After operator new, if the first thing after it is a function call, that is 99% going to be the base constructor. Like the only case where that is not the base constructor is where your class most likely doesn't have a base. It could, but it's empty. And the first member, like the first attribute in your class, has a non-inline constructor. That's the only case where you would see a function call here, and it's not the base. But most likely, it's just going to be the base. There are ways to check, which is like from the destructor, but it's not always reliable. Like here, if we go to the deconstructor, you'll see that there are a bunch of deconstructors called here, but the one that is like the base is called with the value 0. And see, I said this is unreliable for two reasons. The first one is that your class could have a base, and the destructor of the current class is inline. So if this collision manager doesn't actually use this class, and by the way, I don't even use the name collision manager in the decomp anymore. It's just that I'm too lazy to change it in my database. But anyway, see, it doesn't actually use this class. It uses this one, and this class is a base of this class. So the deconstructor of this class here was inlined. Basically, you could say it was removed. If you don't know what inline means, it just means you go to a function, copy everything here, and then paste it here. That's what inlining is. So that's what happened to the destructor of this class. And because of that, I mean, it has a base, right? And I told you each base has its destructor called with the value 0. If it's called with 2, that means it's a member. Like all of these are members. The collision manager is also a member, but because its destructor was inlined, this is basically the call to its base's destructor. So that's why we get 0 here. The second reason I said that this method is unreliable, like finding the base using the destructor, is because the base itself could have an inline destructor. So here, the base of this class, Koribo, is Koribo base, like this. But Koribo base's destructor is inline, so you don't find it here. And then Koribo base also has enemy as the base, and this one also has an inline destructor, so we'll not find it here. Then enemy has a base class, which is actor multistate, which also has an inline destructor, so we'll not find it here. And so on until you reach the actor class. This is the class that doesn't have an inline destructor, so that's the class that you will actually find here. So you will not find any of these classes in the destructor because their destructors are inline. If the destructor wasn't inline, you can use like this destructor function to find the base. But usually, it's more likely for the constructor to be not inline. So that's why it's more reliable to just use the constructor to find bases. But there are some cases where the constructor is inline. That's only for like simple classes. You won't find a complicated class that has an inline constructor. That's like rare. Because sometimes that can cause problems with the compiler as well, like failing to inline and then causing code duplication. Some compilers even like they can't even process it, or they would, but they would give you a warning. Like GCC gives you a warning if you try to inline a function, but it can't because it's big. But Greenhouse, I don't think it gives you a warning. I don't think Greenhouse like faces a problem in this case. But if it fails to inline a function, it will just create duplicates of it. Like that's the one of the worst things about Greenhouse is that when it fails to inline a function, instead of creating one copy and making everything use this copy, no, it will create a new copy every single time that function is used, and that's why like half of this executable is just the seed safe string destructor. It's so bad. I mean, there are some benefits to the thing I just mentioned, which is basically being able to tell um, which functions are supposed to be inline, especially in like virtual functions. Anyway, so the Kuribo class, the first function that is being called after the operator new is the base, which in my case I called it Kuribo base. I think I don't remember if this name is confirmed or not. Usually, when I name a function and the name is not confirmed, I add this void thing. I mean, that's not the reason it existed since the beginning, but it just became a habit. Whenever I have something where the name is not confirmed, I just add this to indicate that, or basically to remind myself, hey, this name is not confirmed. But the actual reason this exists because I first started reverse engineering on IDA. Actually, I was using Kine's database, and basically IDA automatically adds these. So like they're basically the function prototype. When you export your database from IDA to Ghidra, it adds the function prototype to the function name. So that's what happened, and eventually I just stuck with it, even though it doesn't make any sense. Like this is one of the reasons that is holding me back from sharing my database because it has so many random things like this. Like imagine if I didn't just explain this, and someone looked and he was like, "What are these void? What is that? What is that? What do you mean by void?" Anyway, let me see. What other messages do we have? What are the data types you see in Ghidra? Last time I looked, I think I saw something have ints. The built-in types, you can literally find them from here in built-in types. Most of these don't matter. The ones that actually matter are float, which is basically 4 bytes. Yeah, the size matters. When you're doing reverse engineering, you should be careful about the size of each data type. So float is 4 bytes. Int, which is also 4 bytes. Long is not really that useful. It's just the same as int. To be fair, like long is the same as int when you're using greenhouse. Long is signed int, 64 bits, so it's 8 bytes. This int is signed. And signed means it has a sign, so either plus or minus. So when you have an integer that is unsigned, that means it literally does not have a sign. And we know numbers that do not have a sign are positive. So if you have 8, this 8 is positive. You don't have to explicitly write plus 8 like this. But if you write minus 8, this is clearly negative because there's a sign. So if you want to represent minus 8, you have to use an assigned integer because you need the sign. But if it's positive, you don't need the sign, so you can use unsigned int. The fact that the name doesn't tell you if it's signed or not is pain. part of the C and C++ standard is that int by default is signed. I said by default to be on the safe side, but I think like it's always signed. Here also, if you hover over it here in Gedra, it tells you it's signed. But I'm pretty sure it's like in the standard, the C and C++ standard, int is always signed. But the thing that is actually like pain because it doesn't specify whether it's signed or not is char, or is it C? Where is C? There it is. Char here is the signedness of char is compiler dependent. So some compilers by default they treat it as signed, other compilers treat it as unsigned, and Green Hills by default treats it as unsigned, while other compilers like GCC they treat it as signed. That's why actually there's a, I don't know if you would call it a bug, but there is an oversight in the seed library in the code that loads SARC files. It uses this char data type. And like I told you, it's unsigned on GHS, Greenhouse. And it's signed when you're using GCC and whatever else. So this actually creates a discrepancy between Wii U games and Switch games. So sometimes, like if you have an archive where the file names are not ASCII. So, for example, like Japanese characters. Say you use Japanese characters in a file name, and then you try to create a SARC file using that. The result would be different between Wii U and Switch because of this oversight. Like, I guess you would call it a bug in this case. I'm not really sure because it's not necessarily a bug because if you build the SARC file using the Wii U tools, it will work on Wii U games. It's just that it shouldn't use the same method for Switch because the signedness actually makes a difference. Anyway, I missed these types, so let's go back from the beginning. The important built-in types are bool. Byte is the unsigned char. They're the same, but it's unsigned. Char is compiler dependent. The signedness is compiler dependent. I don't know what Gedra treats it as, so I don't use it. I only use it when I want actual characters, like character literals. That's the only time I actually use this type. And strings, char pointer. Other than that, I use schar or byte. There's also uchar, but it's the same as byte anyway. Double is a floating point type that is 8 bytes. It's barely ever used in NSMBU, so you don't have to care about it that much, but I guess you can keep it in mind that it exists. dword is the same as uint. We'll talk about it later. Flow, again, is 4 bytes floating point. Int is a signed integer, 4 bytes. Long is, in the case of NSMBU, it's the same as int. You don't need to care about it. Long double, never used. Pretty sure never used. Long is signed 8 bytes integer. So it's like int, but if it's 8 bytes instead of 4. And I'm not sure, is the signedness like, is it always signed? I'm not sure. But here in Gedra it says it's signed. Pointers, you only ever need the regular one. You can also create like type defs for function pointers. I will not go deep into that. Qword is the same as long but unsigned. So you see long, there's also this SQ word. SQ word is the same as long. So SQ word is the same as long, and dword is the same as uint. Word is the same as short. Qword is the same as long. If you ask me why do these exist, I'll tell you I don't know. I mean, apparently they're common in x86 assembly, but that's completely irrelevant to NSMBU. So you don't really need to care about them. But if you ever see them, this is what they mean. Okay, here's S bytes and S char. They're the same thing. SD word is the same as int. There's SQ word is a string UTF-8. S word, which is for short. What did I write here? This is U short. So like SD word is int, and then S word is short. UChar is the same as byte. There's uint, and uint is the same as U32. You know, 32 in U32 means 32 bits, and each byte is 8 bits. So 32 divided by 8, you get 4 bytes. That's how you know they're the same. Ulong is the same as uint. You don't really need to care about it. Ulong long is unsigned integer, 8 bytes, and then void. Here is U short. Short, short and U short are 2-byte integers. Short is signed, U short is unsigned. WHR 16 is for white character. This is similar to UTF-16. Basically, this is the encoding I told you would use for messages like MSBT files and so on. Basically, anything related to layouts. If you're not doing anything related to layouts, you'll never use this. I'm pretty sure it's never used anywhere except for layouts code. And yeah, I think that's it. Maybe they are used somewhere. I'm not sure. So WHR 16 and you have WHR underscore T. This one, the size is compiler defined, but it's in NSMBU it's the same. These two are the same. And you have word here. So these are the built-in types. You can use them to create new types. When you do here, you right-click, new, I never use categories. Function definition is, you can use it to create function pointers. I never use unions. Like, union support in Ghidra is so bad. I just never use unions. You can create type defs, and the most important part here is structures and enums. The structure, you can create a new structure here. You choose a data type, for example, like uint, and then you give it a name. If you don't know the name, you just leave it empty, and then in the decompiler, they'll show up like this, like these here. These are all not named. Let me drink some water. So yeah, you can just set the data type here, and for each member, you can see its offset and the size of that member. So we see uint here is 4 bytes. But if I see like if I add something like seed, I don't know, color 4f, like this. This is another structure that I created before, so you can create it yourself if you want, if you'd like. And we see that the size here is 16 bytes. The length here is in bytes always. If you want to add alignments, I don't really want to explain what it is yet because it's not really that important right now. You can specify the alignment from here, but usually I just do it manually. I'm just saying this in case you already know what alignment is. If you don't, well, we can speak about it later, I guess. Okay, so are you still following? Well, I guess no. In my mic is working. Yo, welcome. I mean, I barely do them myself. Like the last one I did was several years ago. I don't even remember when. Um, I know I did one back in 2019, but I think I did another one like I don't know, but between then and now, I think I did another one. But I'm pretty sure like the one I did in 2019 was like the custom music list. I think. Welcome to the stream. By the way, I don't know if Baron is still here, but yeah, he asked previously like if the Goomba base is used by anything other than the Goomba and Goomba Brats. Apparently, it's used by Paragoombas. Yeah, and I think it's just Paragoombas, nothing else. Yeah, it's just a single profile here. So it's used by three uh, entities: Paragoomba, Goomba, and Goombra. Actually, Goombra and Goomba use the same class, like this Koribu class. They're the same class, but Paragoomba is a separate class. Like this is the same as Koopa Troopas, you know, the green ones and red ones. They're both one class. So here Goomba and Goombra are the same class, like in the same way. Okay, so I'd like to show you how to create headers, like I said, but I would love to do it on something simple, not an enemy class. I really hate these. Yeah, the Goomba base exists in Wii. Actually, uh, I did remember that, but then I was confused because, you know, the first time when I told you that the Goomba base is used by the Goomba and Goombra, I remembered that I got the Goomba base name from NSMBU Wii, but then I told myself, wait, NSMBU Wii doesn't have Goombra, so why does it have the base? But now like as we can see, it's used by Paragoombas as well. Flower typesetter. Flower typesetter is like extremely simple. It's not even worth creating a header for. It's like I think it doesn't even. I don't think it even has any members. I think it just uses a. I think it sets a global variable and then deletes itself. Let's see. Uh, flower. Flower typesetter. Yeah, it just sets um, a global variable and then deletes itself. That's the whole class. Like that's a whole actor. That's all it does. So yeah, I mean, I did say I would like something simple to create a header for, but this is, I guess, too simple. It doesn't have to be an actor; it can be anything. Um, let's see. I mean, I could create the one for the controller, but it has a base. I prefer doing it for something that doesn't have a base, or like it has a common base, like a known base. Like I don't think you guys really do that. Do anything with controllers, so you probably don't know that much about them. That's why I don't want to do that. Hmm. Maybe I can do one of the tags. Like the tag actors. Problem is that all almost all of these just do a simple thing and then delete themselves. G center. Okay, this one it doesn't delete itself, but that's because the distant view code tries to find it. So it just saves the position and then waits until the distant view code finds it and then just uses that. I mean, I already decompiled this file so you can look at it. Okay, this is something. Huh. I mean, this is something, but I would need to create a header for. I mean, wait, I said a header, not decompilation. So creating a header for this thing would be simple. But still, I would prefer something simple, like something that doesn't have a base, because I want to show you basically how like everything related to creating a header. Okay, not everything because that would take too long. That means I shouldn't be looking at actor classes. Hmm. Layout classes are complicated. Yeah. Layouts are the last thing I was working on before quitting for a while. But layout classes are complicated. It's gonna be hard. Bro, I've been working on this database for like 5 years and it still feels empty. How? To be fair, most of this stuff is just actors because there are so many actors I haven't reverse engineered yet. So that's one of the reasons. Anything in the chat? Getro 11 point something added bit fields to structs. You could make the setting nibbles more readable with that. Maybe I could try looking at that. I think I heard about it, but I never actually used it. And give me something SMH. Okay, these are the graphics classes, and I think I did almost all of them. So, I mean, there are some things that didn't do, like the me classes, the database related classes. I haven't done these. Item base. Where's time? I guess I could do one of the layout classes, but honestly, I don't even know what's the most simple one. Maybe the darkness frame. Okay, the darkness frame doesn't have that much. Yeah, it's pretty simple. Well, I guess this means it's visible. Yeah. Symbols, there are. I mean, if you mean functions, the functions are sorted by like their references. So, okay, no, that's a bad way to explain it. Normally, functions are sorted by their order in the class definition. So not even in the CPP file. Like if you change the order of the functions in the CPP file, like the implementation, it's not gonna change anything. By default, they're sorted by their order in the class definition. So like for example, let's see. You open any class here. For example, let's take this class. Bad example, they're all inline. Okay, let's see. No, these are also inline. Okay, for example, this class here. These functions in the executable, by default, they're first sorted by this order here. So if I, for example, if I change this and this, if I change their order, the by default they would be swapped in the executable. The reason I keep saying by default is that there is something that changes the order after this, which is basically references. So, if, for example, if this function, which is placed after this function, if it's referenced by it, the compiler would move it above it like this. Even if the functions are so far apart. So for example, if this function here, set default, if this function uses this function here, the compiler would move the function right above it like this. And I guess the reason for it is cache locality or something. I guess better for it's better for the cache if all related code is close to each other. That's how it orders the functions. But if you mean how it orders the files themselves, they're just sorted alphabetically. But it does respect the folders. So it's not like NSMBU. NSMBU just it ignores all folders. It just takes the file names and like the base file names, and then just it sorts the code based on the file name. But Greenhills, it sorts the entire file path. So it's based on folders. Anyway, let's close all of these, and I guess I can create this. I mean, I don't see anything else. Where is this? Oh, okay. Okay, so let's create a header for this class. Now, here's the thing. All code that is defined in a single CPP file, you will find all of the functions next to each other. So all of these functions are defined in the same CPP file. If there's a function that is defined in the same CPP file and is actually used, you will never see it like somewhere else. It must be next to these. Like the compiler groups all functions in the same CPP file together. So, for example, this darkness frame create function, there is no way it would have been anywhere else. Like for example, like here, for example, it wouldn't have been here. It must be like next to the other darkness frame functions, basically next to the other functions that are defined in the same CPP file. So what you can do to find all functions in the same CPP file, I mean, there's no there's no perfect way to do it, but there are like hints you can use. These empty deconstructors are 99% seed safe string deconstructors. Like for example, this is the like assure termination whatever virtual function for the buffered safe string. But my point is that all of these are inline functions, and inline functions are placed at the end of each CPP file. So when you see deconstructors like this means this is the end of some CPP file. So that most likely what that means is that the next function that isn't a simple one like a deconstructor or like, you know, this thing, that most likely the next function is going to be the start of the next CPP file. So when you see deconstructors like this, and then I see, okay, the next function is a constructor, then I know that whatever came before this is a different CPP file, and this is another CPP file. So you can basically start reverse engineering from here. If you don't like this method, you just find the constructor and start reverse engineering from there and go down. 99% of the time, the constructor is going to be the first function in the CPP file, unless it uses other functions. Like, for example, if this create function, as I explained it a while ago, if this create function was called here, the compiler would place it above this function. So unless like other functions of in the same CPP file are called here, 99% of the time the constructor is going to be the first function in the CPP file, and that's because Nintendo themselves, when they define classes, they usually put the constructor at the very top. So if I go back to the same class, it wasn't this one, but okay, it was this one. The constructor is usually the first function they define. So it's based on this that usually the first function in each CPP file is the constructor. But if I take this constructor and if I move it down like to the end, you will see that in the executable is actually the last function in the CPP file before the inline functions. But like I said, luckily for us, 99% of the time, Nintendo defines the constructor as the first function. So usually it's the first function in the CPP file. So what you can do is that first you find the constructor and then just reverse engineer all the functions that are under it. And usually it would be like you would basically find all functions of this class. There are other there are better ways, better in the sense of like accuracy, not in like speed, which is finding the references to this class. So for example, this class is being created in this function, and it's being stored in this variable. It's a pointer. So this function is a function in the area task class. And if you already know all functions of the area task class, you can just find all references to this attribute and just check all the references. It's either going to use it, it's either going to access it directly, or it's going to call a function using it. And these functions are going to be the member functions. So that's a different way to find the member functions. Like the easier way, the faster way, but it's less accurate. It's just to check the functions below the constructor. These are 99% of the time are going to be the member functions of this class. Otherwise, you can just, like I said, the long way, but it's more guaranteed, is that you search for the references to this class and then follow each reference. Is there no ASLR? No, there's not any ASLR. Have you mapped out the game source folders from the TU order? Yes, I did. I actually showed it earlier. So I have it in the Miyamoto Discord server. And it's also in the decomp. Or like the headers repo. If you check it, it's the same order. Yeah, like this. There are more folders, but first of all, I didn't update this for a while, so there are more folders. But secondly, I think I already hit the characters limit. Oh, yeah, like I have like 58 characters remaining, so that's another reason like I didn't update this list. But if you'd like, you can also just check the headers repo. Like here, you can just check this. Okay. I'm reading the chat right now. Why are the virtual functions referenced from read-only data? I mean, that's where the virtual function table is. Like, look, that's the that's the VF table. So that's why they're referenced from here. Like this. Wouldn't it based on where it's defined in the CPP file and not the header? No, like I said, it's where you define it in the CPP file is irrelevant. The important part is the order in which they are declared in. The declaration is what matters. So, like I said, if you take this function, the set geometry shader, and you move it all the way, even above the constructor, and you build the code, it's actually going to affect the order. Even though I didn't modify the CPP file at all, if I save this and I compile, you'll see that this function set geometry shader will be placed before the constructor. So the order is based on the declarations, not the definitions. I mean, unless you define the function directly here. I mean, if you define the function directly here, it's going to be inline. But if it fails to inline it, it's going to place it at the end of the CPP file anyway. That's where it places inline functions that fail to inline. Like I said, the seed safe string functions. That's where it places them at the end of the CPP file. Otherwise, it depends on the declaration here. So if set geometry shader is declared before the constructor, is going to be placed before the constructor in the executable, regardless of the order in the CPP file. And you can test it. I can test it as well, but I'd rather not to save time. I tried to map out 3D lands to use, but the linker sorts all symbols alphabetically by their mangled form, so it was impossible. Yeah, I've looked at 3DS symbols before. Well, the order was confusing. I don't remember if it was sorted. Maybe it was because I was actually looking at the demangled symbols, so maybe that's why the order didn't make sense to me. Yeah, I was confused because in Switch there are reference from .data because of ASLR and the pointers needing to be relocated, so it's not read-only data. I mean, even on Wii U, like relocations still happen. It's not because of ASLR, because I think ASLR is different from what is being done on Wii U. But on Wii U, it's like it still relocates the code. It's just not. It's not random. Like it's relocated to a specific address. But since it is relocated, it has to update all pointers. So even the pointers in the read-only data section, even though it's supposed to be read-only, it actually does modify this section to like update pointers there. Excuse me. All right. Okay. On Wii U, basically, it really relocates the code because the original address that the code is placed at is reserved for like RPLs and so on. Like for example, if I go to the top here, the first the first function is placed at this address, but like on actual hardware, this address is reserved for user RPLs. RPLs on Wii U are like DLL files, and users can create their own RPL files to basically create something similar to DLL files. So the code for the RPL files would be placed at this address. So your game code or like your application code will be moved from this address somewhere else that is defined based on an XML file that is in the game files. So since it moves the code, it needs to update all pointers. So it also has like relocations. Like here, the sections you can see, it has relocation sections here. Now I don't know if I should start now because Byron said he'll leave for a bit. So maybe I guess what I can do right now is to show you that changing the order here actually changes the order in the executable. I guess I can show you that now. Let me close these first. And oh my god, so many. I believe I added all files here. Actually, I should just use the other one. Why am I using this one? No, hold on. I don't need this one. Okay. Okay, so this is my NSMBU decomp project. So let me also open this folder instead. So here, if I go to, what's it called? What's it like shader optimization thing? Whatever. Okay, it's not this one. Oh yeah, it's not in this folder. Oh my god. It was this folder after all. Whatever. So AJL shader, compile info. No, I need the other one. Optimize info. Okay. So you can open this, and I'll also open the CPP file. Optimize info. Here it is. Did I not decompile these? Where are these functions? Guess I didn't decompile them. Huh? What? Huh? Interesting. Oh yeah, I didn't decompile them. So I guess I mean, I could still use this example. It's just it's kind of more stupid now. Yeah, see, set default, it call like the constructor calls set default, even though set default in the header comes after. So in the executable is placed before it. So I told you the compiler moves any functions that are referenced by other functions in the same CPP file. They're moved right above them. So this example will not work. I mean, it could work. I could move the destructor up, I guess. Actually, I don't know if this destructor follows this rule. And I think it does. So, see here in the CPP file, if I drag the destructor to the very top, so now it's the first function in the CPP file. If I do that and I save and then I compile, let's see what will happen. Amazing. I forgot to update the decomp. I need to use the same case seed. Wait. Where is this from? What? It doesn't even appear. What? Oh, it's not the correct window. Might be. Yeah, I mean, I'd need to update the headers submodule. So, um, oh my god. Okay. Yeah, this should be sys now. Okay, let's try it again. Okay, it works now. Okay. 1 minute. Okay. All right. So we said the structure of this class. Let me do some stuff while it analyzes it. See now here, the symbols are sorted by address, and we see that the constructor and set default are both still before the destructor. Like here, the constructor and set default are still before the destructor. So even though we put the destructor at the very top, it didn't really change um, anything. So if I undo that, okay, so I undid my changes and I moved the destructor where it is. So it's in the CPP file, the destructor is after the constructor. But in the header, if I take the destructor and I put it at the top like this, and I compile again, now let's see how different the result would be now. And I don't need this anymore. I'll have to reopen it. And obviously, since it's a header, it's referenced by other files, so we need to recompile these. Okay. Okay. See now, here's the constructor, here's the set default, and here's the destructor. So the destructor now, since we changed the order in the declaration, so we changed the order of the declarations, and that resulted in the order changing in the executable. So now the destructor is before the two functions. Remember when we changed the order in the CPP file, it was after, but since I changed the order now in the declarations, it's before, even though in the CPP file, it's still after the constructor. Like, see now the order in the CPP file doesn't matter at all. Like, in the actual executable, the constructor is at the very end because set default is moved above the constructor since it calls it. And the destructor is the one at the very top because that's just the order in the declarations. If the constructor did not call set default, I can comment this out. If it doesn't call it, it will not be moved. So the actual order that we will see in the executable will be like this: the destructor, the constructor, and then set default. Before I recompile, just let me confirm to you that here the order right now is deconstructor, set default, and then constructor, because the constructor calls set default. but I commented that line out, so it shouldn't move set default above the constructor anymore. So that order should be the same as this here. And let's compile it and try it. See? Now, this is the same order as the declarations. First, the destructor, and then the constructor, and then set default. Set default was not moved above the constructor because the constructor no longer calls it. So that's how code is ordered in by DHS. By the way, deleted functions still keep their effect. So, for example, if I have a function, like a mysterious function that I add here, like void do something, like this, and I take this function, I implement it, I place it at the top, like this, and in this function, let's say I call set default. Let's say set default itself is used in other places. So it's a used function, it's not unused. Again, let's assume that set default is used somewhere even other than this function here. Let's say it's used by the constructor as well. Actually, that's a bad example. Let's just assume it's used somewhere other than here. And this do something function, it's unused. It's not used anywhere. Nothing calls this function. So by default, GHS will remove unused functions, but their effects will remain. So since this do something function is placed at the very top, it will come at the very top. And it calls set default. So set default will actually be moved in the executable above this do something function before it's deleted by the compiler since it's not used anywhere. So let's assume we did not know that this do something function actually existed. And since it's unused, it will be deleted. But the actual order that we will see in the CPP file or like the executable will be like this. Like set default will be at the top, even though nothing calls it that makes it makes it placed at the top. So that might trick you into leading that Nintendo maybe like placed it at the top like this, but that might not be the case. The actual reasoning could be that there used to be a function placed at the top that called this function, and due to that it was moved up, but that function was actually deleted by the compiler. Just undo all of this. Okay, so that's all for this part. Okay, I'll need to leave in 18 minutes to go pray, and I think I'll be back after that, like in 30 minutes after that. So I currently have 18 minutes, but I don't know what to do, honestly, in these 18 minutes because the star of the show is not here. So I could do the thing he requested now and like have him watch it later, but I'd rather do it while he's here because, like, in case he has questions, I could answer them on the spot. Well, if no one else has any questions, I'll just pause here, and then I'll be back in like 50 minutes from now. Unless anyone has any questions, but if no one has any questions, I'll be back in like 15 minutes from now, like 50. Mm, I'll wait for a bit, but I guess no one has any questions right now. Okay, yeah. Guess I'll stop for now, and like I said, I'll be back in like 50 minutes. Well, I hope you enjoyed this. Wow, it was almost an hour and a half, but I feel like I didn't achieve anything amazing. Anyway, I hope you enjoyed the stream, and if anyone is available in 15 minutes from now, I think I'll just like do another stream in case anyone wants it. Anyway, I'll see you later.